Hello and welcome. My name is Dr. Jasmin Cowin, and I will be presenting from my own metaverse in Agora, a no-code platform for the voices at the cutting edge of conversational AI. My topic, AI, avatars, and 21st century simulation training for educators. AI and intelligent systems are positioned to become change agents in education through ushering in profound changes in institutional administrative functions, systemic strategic planning, and program planning. Post-pandemic, the explosive growth of fully accredited online degrees has also reached teacher education programs. And in this presentation, I will explore applications and education use cases of augmented reality digital technologies for educational organizations during the fourth industrial revolution. And the fourth industrial revolution requires vision, flexibility, and innovative educational conduits by governments and educational institutions to remain competitive in a global economy while simultaneously working towards new governance structures aimed to mitigate external interruptions and algorithmic biases driven by artificial intelligence or algorithmic models. Educational organizations will need to focus on teaching and learning and continue to offer knowledge relevant to 21st century markets and changing labor force needs. Implementing contemporary disciplines will need to be embodied through learners' cognitive knowledge-making experiences. So let's take a look at 21st century learner dispositions. So here is an infographic that I designed, and the learning dispositions or habits of mind refer to the way in which learners engage in and relate to the learning process. This is independent from using AI. This is within us. So learners need to have a sense of belonging, taking an interest or participation and contributions. There has to be a sense of well-being, being involved through self-management, exploration, persisting through uncertainty and challenges, communication, where we express ideas and feelings through language, symbols, or text, confidence, believing in oneself and power and abilities, problem solving, posing hypothetical problems and recognizing discrepancies that require further investigation, embarking on new learning experiences, which is connected to motivation and flexibility, and of course, metacognition. Those are the important 21st century learner dispositions, and they are independent, as I said, of AIs. This is what an AI is supposed to nurture. And then when we are looking at simulation environments, there we have then the ubiquitous accessibility. So let's take a look what it would take to implement new technology into an educational institution. So institutional educational institutions, you have an institutional culture, you have an educator culture, and you have a learner culture. But before you can move on, really in the institutional culture, the system-wide understanding and general conceptions of teaching and learning in three-dimensional spaces, such as metaverses, have to be clearly articulated, and you have legally vetted approaches to creating or configuring 3D immersive learning hubs, such as metaverses, including the use of AI. Those are ethical considerations. And then there has to be a determination on 3D learning space integrations as a vital part of university culture and learning systems. Now, the educators need to co-construct and implement these 3D learning spaces together with design teams to support both learning and teaching. So when we talk about algorithmic biases, it needs to have more than one set of eyes before you end up with an end result of an algorithm. The 3 teaching must be purposefully orchestrated and rely on sound pedagogical principles and purposefully and meaningfully engage learners with learner-centered instructional activities. Yet, our learners, whom this is all for, need to have these learner dispositions spoken to, right? So, learners need to recognize and value these benefits of 3D immersive spaces for acquiring content knowledge. And these 3D activities together with an AI have to be aligned with their learning preferences, together with the idea that the avatars are appropriate and representative of the learning instructional activities that you're doing in this space, because this isn't Second Life. So in order to look at what AI avatars and simulation spaces can do, I am going to review, contrast, and frame 2 distinct ecosystems, Mercian, which is Teach Live, and SimSchool. So while both platforms offer immersive experiences, SimSchool is AI-driven, while Mercian employs mixed reality simulation. So Mercian also Teach Live is on the right-hand side, SimSchool is on the left-hand side. Both provide pre-service teachers and practicum candidates a platform to practice and rehearse the art and skill of teaching within a controlled simulation setting using avatars and AI. Insights on effective evidence-based practices by teachers and teacher candidates are generated through data from both AI and candidates' in-world experiences. Such data aggregation offers institutions informed decision-making through a systemic review using technology to improve teacher education programs. So let's look at what the differences are. So mixed reality simulations, learners interact in real time. It's a blending between AI and live human interactions. These cannot be on-demand activities, but it's validated through independent research, fully customizable on demand. It supports the training and support, but it has a human-in-the-loop technology specialist. Whereas a fully driven AI is usable 24/7, asynchronous, AI-driven, support 7 days a week, also validated through research, fully customizable, and it has automated real-time reporting, and both of them have live measures of implicit bias and teaching effectiveness. What does this mean? So let's say that you have access to such training platforms. It's more than just simulation training. It really offers an equitable access to achieve SDG 4C, which is by 2030 substantially increase the supply of qualified teachers, including through international cooperation for teacher training in developing countries, especially in least developed countries and small island developing states. Divergent and reflective thinking. So 21st century competencies for teachers are centered around divergent and reflective thinking, and simulations are very useful in nurturing and risk-taking and flexibilities in safe spaces. So in a simulation, This divergent and reflective thinking can be nurtured through creative, original, and varied classroom teaching, imagination, flexibility, and intellectual risk-taking. Remember, these are safe spaces. This also encourages open-mindedness to others' ideas, adapting to changes in learning situations, and of course, accepting new or changing technologies. So reflective thinking is really a 5-level model: reporting, responding, relating, reasoning, reconstructing. And in this case, in a simulation, the AI reports the data, right? And teacher candidates or teacher trainees or even teachers in professional development respond to a classroom task, relate to the students and the avatars, and within the simulation space, they make decisions based on their own reasoning and teaching experiences. And then, unlike in a real classroom environment, they can reconstruct the complete experience a second time after receiving feedback. Why is this so important? So Holland IQ, in its 2018 report, Education in 2030, predicts that global education and training expenditure is set to reach at least 10 trillion by 2030, as the next decade will see an additional 350 million post-secondary graduates and nearly 800 million more K-12 graduates than today. So in numbers, that means that the world needs to add up 1.5 million teachers per year on average, approaching something like 100 million in total. Post-secondary education will undergo the biggest expansion and change, as the role of the teacher represents more than that of a mentor and coach or sage on the stage. So what's in this AI? Well, AIs are constructed by experts and specialists, and they, in this particular case for SimSchool, it weaves models of cognition, emotion, and behavior into complex algorithms that drive dynamic, unscripted action. So we have the model of psychology, interpersonal circumplex theory, the zone of proximal development by Vygotsky, expectation states by Berger. But what does this all mean in practical application? So let's take first SimSchool and then Mercy and Teach Live. So what you see here are the student avatars depicted. They don't move, they sit at their table. So these student avatars are powered by this artificial emotional intelligence software that has the components that I just spoke to in a safe, risk-free virtual space. This is an alternative way to connect the theoretical framework of teaching and practicum teaching with practice-oriented simulations. And then the teacher candidates are offered feedback and opportunities for field faculty or for departments or universities to set tasks. This could even be done by a state department for education, that a teacher has to pass a certain task-based section of training before they can go live into a classroom. So let's take a look at these SimSchool personalities. So these virtual students have executive function, subject matter specific capabilities, emotions, and reasoning. They also have gender preferences, physical traits, and they have the ability to tell you how they're feeling or show that through their facial expression or body expression. So let's take a look at Dolores, okay? So if you were a teacher educator, or if you were a teacher that were using this, you would go in, you would click on Dolores, and then you would see her makeup, the decision reaction time, her academic language skills, and so on. So there are three classes of components that go into this. There are 5 traits and needs, 17 learning preferences, and a variable for social expectations. So, same idea in Tech Life, that's Mercian. You have these virtual characters, but here's the major difference. This also involves human interactors. That's the human in the loop, and I'll get to that in a minute. So you have, just like the other one, you have your student avatars. They're aligned William Long's classification of adolescent behavior. You're working within simulated time constraints, but with the human interactors, there is a really deep presence, immediacy, and immersion. And again, your student avatars come with a menu so that the teacher who's working in this environment can have a fuller picture of whom they are working with, because after all, one is simulating a classroom environment. So this is how it would look like if you were to have a mixed reality interaction. Somewhere in the world, there is a teacher to be trained for a specific task, or for a specific lesson plan, or for specific social emotional learning. And they are working with these avatars. Yet on the other side, somewhere far away, there is a studio with that human in the loop. So this gives a sense of immersion that feels like a real classroom with real students, a situation of plausibility, and a place in illusion. So these are, though, yet 2 totally different environments. One mixed, one AI, fully AI driven. So simulations and divergent and reflective thinking for teacher training. So here candidates really were able, that's what the research shows, to feel, think, and behave authentically regarding the situations depicted in the scenario. They developed higher order thinking, divergent, reflective, and creative thinking, and expanded their repertoire of behaviors. So I love creating infographics, and I thought, let's take a look at what this actually means when you take something like this as a whole ecosystem and you try to visualize it. So I created the Sim School wheel. I tried to imagine how the complexity can be unbundled so one can visualize it. So here we have these Sim School cloud-based classroom simulations that support teachers' reflective practice. So it's AI-driven, autonomous, asynchronous, accessible, age pre-K through 12. When you take a look at this, and these Sim School data reports generated by the AI align to standards. So in education, we have INTAS, we have a Danielson framework, we have multiple state standards, custom disposition instruments, you name it. And so because it's an AI-driven instrument, it can implement any educational task standards. Then it weaves these cognition, emotions, behaviors into complex algorithms. So what? So the Cattell, Horn, Carroll, the ocean model, all of those are then surrounding this idea of this simulation space. That's how I imagine it, and that's how I visualized it. So some of the embodiment components, these avatar systems, these characters, they use lip synchronization, speech recognition, speech synthesis. But this is the phase that our students, teacher candidates, and eventually probably students, these are the phases that they're seeing now. However, eventually, we will be looking at something completely different. We will be looking at digital humans that very closely, or perhaps represent human interaction. So bots, digital humans, robots, virtual beings, virtual humans. So these are this is the future. This is a world of digital humans that could be avatars within a simulation space, interacting with students, with teacher candidates, and so on. So these digital humans will really speak to the macro trends of the Gen Z generation. And those are high expectations for flexibility, personalization, and hyperconnectedness. So these AI and AI-enabled hyper personalizations are an example of connecting to those demands through automating basically student-centered learning. And such personalized competency-based learning is driven by these AI-generated personalized learning profiles. And these learning profiles then, together with individually constructed learning paths, can be aligned to the specific needs of the learner. Now, this changes the way that knowledge is generated, distributed, and converted, because that is directly tied to big data aggregation and the AI. And that raises fundamental questions on whether humanity will continue to be in the control of its future in the face of exponential automation, because I feel that there are unresolved issues regarding algorithmic biases, allocative harms, unequal access and benefits, and trade-offs between efficiency and creativity. Right now, there seems to be no governance mechanism in place within the United States or any university accreditation institution discussing and addressing AI and these augmented reality digital technologies and their impact on our neurological makeup. Yet avatars will be pedagogical agents in digital learning, because these avatars actively signal the learner's attention to relevant information through commentary, facial expressions, or other methods. I want to look forward and talk quickly about Whisper. Whisper is an automatic speech recognition system, and I've tried it out, that enables robust transcription in multiple languages, as well as translation from those languages into English. So it's really looking forward. Language-oriented models are becoming multilingual, and I believe this is happening because there are common threads in linguistics, such as lexical similarity, defined as a measure of the degree to which the word sets of two given languages are similar. Lexical similarity can be used to evaluate the degree of the genetic relationship between two languages. However, lexical similarity is only one indication of the mutual intelligibility of languages, since the latter also depends on the degree of phonetical, morphological, and syntactical similarity. So when understanding sentence construction between different languages, we might have different rules, but we'll still have things like nouns, adjectives, subjects, prepositions. So those are those similarities. And it seems by training models on many languages, there is a more robust understanding of language. Just like in the image generation models, that multimodal networks are more powerful than a single purpose network. So those multi-language models seem to be more robust. So as we move towards more advanced AI systems, we might see more and more generalizable networks with distinct advantages over separate networks that get plugged together. But what does that have to do with anything here? So if our bots, if our digital twins, if our digital humans, whatever you want to call them, use these natural language ability, right, with the automation, and they can speak in 5, 6, 8, 12 languages, That also means that they will be able to work with teachers from those least developed nations and small island states. In the end, all of this is really how to build these building blocks for learning and 21st century competencies. So interpersonal, work ethic, agency, self-management, cognitive, executive function, self-direction, knowledge, curiosity, resilience, and then intrapersonal, this leadership, the self-awareness, teamwork and collaboration. Those can be built in these simulation spaces powered by AI. To bring those classrooms for the future. So education and work might unfold as a fluid panorama for job seekers in an environmental, geopolitical, volatility, uncertainty, complexity, ambiguity, also called VUCA environment. The importance and presence of brick and mortar educational institutions will most likely diminish in the near future as online learning, learning management systems, metaverses, together with artificial intelligence driven in world interactions are on the verge of breakthrough adoption in the educational market space. To sum up, simulation-based learning and AI is here to stay, but some fundamental questions arise on whether humanity will be in control of its future in the face of this exponential automation, because there are unresolved issues regarding algorithmic biases, allocative harms, unequal access and benefits, and trade-offs between efficiency and creativity. As I mentioned before, that there are no governance mechanisms in place to the United States governmental or any accreditation institutions discussing these impacts. Now, as the world grows more complex, access to more learning opportunities through simulations provide ubiquitous learning opportunities and experiences in both online and virtual environments. Along with expanded access, I believe that learners will grow into more sophisticated edusumers, looking for virtual or augmented environments and non-traditional micro-credentials. So creating these novel tech experiences in 3D environments promise to prepare learners in institutions across national boundaries for the fourth industrial revolution, which according to Klaus Schwab, chair of the Economic World Forum, is characterized by a range of new technologies that are fusing the physical, digital, and biological worlds, impacting all disciplines, economies, and industries, and even challenging ideas about what it means to be human. So simulations and AI lower the barriers of entry and have the potential to provide universal access to education and upskilling. So as more people can access education, individuals have the opportunity to upskill and eventually increase their potential and lifetime earning power. However, in the best scenario, these educational pathways through simulation and AI will allow each person to contribute to society while making informed decisions beneficial to themselves and their communities. Yet, I believe this ongoing fast-paced transformation of knowledge generation calls for humility in the face of AI's detrimental impacts on the creative, individual, authentic development of learners' full potential, their creative spark within. We know the drop, but we don't know the ocean. Thank you for your time, and I appreciate the opportunity to give this presentation. Goodbye.